A hush from the cosmos arrived nearly half a century ago. 72 seconds that changed how we listen. A radio burst, recorded in 1977, erupted from the direction of Sagittarius and then evaporated, leaving behind a single astonished note written on the technician's printout. Decades later, that same swath of sky is delivering something far more tangible, a foreign body racing into our neighborhood, carrying chemical oddities that refuse easy explanation. Two enigmas, one coordinate, 48 years between them. Stay with me as we untangle whether this is the universe playing statistical tricks, or whether humanity may be standing at the threshold of its first deliberate exchange with an intelligence not of Earth. 48 years earlier, an instrument in Ohio registered an anomaly that did not fit known astrophysical patterns. The signal's characteristics were unusually narrow, perfectly tuned, and arrived at a frequency many radio astronomers treat as a natural calling card. The observer circled the printout and wrote a single, stunned reaction that became part of lore. It pointed back to the crowded stellar region toward the Milky Way's core, then disappeared as if it had only dropped by to say hello. For decades it has been a question that won't quit. Now in 2025, a newcomer has emerged from roughly the same celestial neighborhood. Unlike a whisper carried by radio, this visitor is material, a compact object on a trajectory that makes it clear it did not originate inside our solar environment. Detected by surveys operating from high, dry plateaus, this body follows a hyperbolic path. Calculations show its motion is unbound to our sun, the classic signature of an interstellar traveler. Its discoverers gave it a name that marks it as the third confirmed interstellar entrant we've ever charted. For the first time we can measure, sample, and spectrally dissect matter that formed around another star. What raises the stakes is not merely the coincidence of direction. The original radio blip sat at 1420 MHz, squarely inside a spectral window scientists often call the waterhole. That segment is flanked by signatures of hydrogen and hydroxyl, a quiet band in an otherwise noisy radio landscape, a natural meeting frequency many agree would be obvious to any technologically capable communicator. Neutral hydrogen exhibits a precise transition there, a universal tick embedded in atomic physics. It's the sort of cosmic constant any advanced civilization could choose as a shared reference, a lingua franca written into the universe itself. But direction and frequency alone do not make proof. The real puzzle emerges when we look at the newcomer's chemistry. Early infrared and optical spectra show ratios of molecules and elements that diverge dramatically from the norms we know for comets and small bodies born inside our star's realm. Instead of the water-dominated signatures typical of local comets, this object's atmosphere exhibits a disproportionately large fraction of carbon dioxide relative to water vapor, measurements that suggest a CO5 to HATO ratio several times higher than what we expect from native cometary populations. Instruments tuned to measure atomic emissions returned another surprise. Lines associated with nickel flared while iron features remained conspicuously faint, a combination that challenges standard formation and outgassing models. Physical size estimates sharpen the mystery. High-resolution imaging constrains its dimensions to an upper bound, only a few kilometers across, maybe substantially less, yet its activity, dust and gas production, appears far more intense than what we typically observe from comparably small bodies. In other words, it's performing like something larger, or operating by a set of chemical rules unfamiliar to our catalogue. That mismatch between scale and output has provoked fresh debate in laboratories and observatories across the planet. This moment gives researchers something they rarely enjoy: time. Previous interstellar visitors sped through our system so quickly that telescopes could barely swivel in time. A decade ago we saw a brief, tantalizing interloper that disappeared almost as fast as it arrived. More recently another passed that allowed slightly longer monitoring, yet still left us longing for deeper analysis. The current visitor's path, however, provides months of access. Spaceborne observatories and ground arrays are already coordinating campaigns to trace its composition, rotation, and changing behavior as sunlight awakens volatile compounds hidden beneath an alien surface. We can now perform what amounts to a forensic examination on material that condensed in a different stellar nursery. History, though, warns caution. Astronomy's archive contains episodes where initial mystery yielded to mundane explanation after richer datasets emerged. Pulsars once prompted speculation about deliberate signals. Fast radio bursts stirred talk of exotic origins until patterns became clearer. Scientists must apply skepticism and rigorous cross-checking because extraordinary conclusions demand extraordinary evidence. Instrumental quirks, regional radio interference, or rare natural mechanisms can masquerade as something intentional or foreign. Yet the alignment of two puzzling events from the same patch of sky is not trivial. In a cosmos containing perhaps 2 trillion galaxies, each with untold numbers of stars, the odds of two of our most puzzling detections converging on the same small region by chance alone seem vanishingly small. When you add that the earlier radio anomaly occurred in the waterhole band, the place any savvy cosmic listener might pick, and that the newcomer originates from the same visible direction, the coincidence becomes uncomfortable in its statistical unlikelihood. Consider also where Sagittarius points us toward the inner reaches of our galaxy, the dense arena around the supermassive black hole, anchoring the Milky Way. That sector is a hub of energetic processes, crowded with stars, dust, and radio noise, an environment that both encourages the generation of natural radio emissions and complicates the task of differentiating engineered signals from astrophysical clutter. If a civilization sought to broadcast where signals would carry far and be noticed, the galactic center's prominence would make it an attractive address, despite the sensory chaos. At present, we stand at the boundary between disciplined doubt and imaginative possibility. Observers continue to gather spectra, polarimetric data, rotation curves, and high-cadence photometry. Laboratory groups are rechecking calibration records, simulators are running formation scenarios, and theorists are exploring whether known physics can account for the odd elemental mix and the unexpected activity. If conventional pathways fail to explain all the data, the bar for invoking intelligence will remain high but no longer hypothetical. For now, the prudent posture balances curiosity and rigor. We must let evidence accumulate. Still, pausing to imagine what a deliberate exchange might look like matters, not because we should leap to conclusions, but because preparation sharpens interpretation. Whether this is an extraordinary cosmic coincidence or a first faint echo from an intelligent neighbor, the consequences are profound. Either way, the cosmos is talking to us in two very different tongues from the same corner of the sky, separated by nearly half a century, and we are finally listening with everything we have. This story will walk the line between open curiosity and scientific discipline. We'll follow the evidence wherever it leads, separate speculation from measurable fact, and let the data shape the narrative rather than letting our wishes get ahead of us. We'll revisit the roots of both puzzles, track the latest investigations, and weigh explanations ranging from the ordinary to the extraordinary. It's entirely possible that the strange radio signal and the wandering interstellar object share nothing more than a cosmic coincidence, two mysteries linked only by our instinct to search for patterns in the chaos of the universe. Yet their convergence still gives us something of immense value, a chance to reflect on how fragile and incomplete our understanding of the cosmos truly is. As 3 Atlas swings past Mars in October, circles the Sun and eventually drifts back toward the interstellar dark, we are being offered a fleeting window to observe, to analyze, and to wonder, because in a universe where 2 riddles from the same sector of sky arrive at our doorstep, every possibility suddenly feels closer. Let's turn the clock back to the night the first mystery began. August 15th, 1977. Across the United States, most households were fast asleep. But out in Ohio, a peculiar machine called the Big Ear radio telescope was sweeping its gaze across the heavens. Unlike the dish-shaped antennas that dominate our imagination, Big Ear resembled a long trough stretched across farmland, nearly 1,000 feet of metallic surface capturing faint radio whispers from above. Its design relied on Earth's rotation to scan the sky. Each patch of space passed through its listening beam for only 72 seconds per day, no more, no less. If something unusual appeared, astronomers couldn't simply swivel the telescope to take another look. They had to wait another full day for the sky to roll past again. On that summer night, as the stars of Sagittarius slid into the telescope's range, something remarkable occurred. A sharp, narrow signal appeared on the receivers, centered almost exactly at 1420.455 MHz. Over the course of 72 seconds, its intensity climbed, peaked, and faded away with perfect symmetry, exactly matching the profile of an astronomical source crossing Big Ear's beam. For those familiar with the hydrogen line, that frequency was more than a technical curiosity. It was the one place in the spectrum many had argued would be the most logical beacon for interstellar communication. The next step in the story belongs to Jerry Amon, a volunteer astronomer reviewing the printed data days later. The computers of the time translated signal strengths into a string of numbers and letters on reams of paper. Most of the printouts were filled with dull rows of 1S and 2S. The quiet background of space, but Eamon's eyes froze on an extraordinary sequence. 6 EQJ5, the pattern rose and fell like a perfect bell curve, standing out like a flare in the night. Stunned, he circled it with a red pen and scribbled a single word into history. Wow, that offhand reaction would become the name by which the signal is still known decades later. The WOW signal looked like the archetype that SETI scientists had always dreamed of. Its narrow bandwidth suggested artificial origin, since natural sources rarely produce such finely tuned frequencies. It seemed fixed in space rather than moving like a satellite or passing aircraft. And most intriguingly, it sat almost exactly on the hydrogen line, the 21-centimeter wavelength thought to be a universal calling card across civilizations. For SETI researchers, it was the closest thing to a shout from the stars they had ever seen. Big Ear's design introduced both strength and limitation. 2 feed horns sat side by side, allowing the telescope to scan 2 adjacent regions of the sky sequentially. A true celestial source should have appeared in both beams a few minutes apart. The WOW signal appeared in only one, leaving its exact position uncertain and complicating all follow-up efforts. The Ohio team immediately recognized the importance of the event and began redirecting other instruments toward the suspected area. No repeat ever came. The burst had vanished, leaving only its trace on a sheet of paper. In the years that followed, the WOW signal became the most chased ghost in SETI's history. Radio dishes around the globe joined the hunt. The Arecibo Observatory in Puerto Rico, the Parkes dish in Australia, the Very Large Array in New Mexico, and many more all searched that same patch of Sagittarius, sometimes for days on end, sometimes intermittently over decades. Not once did anything similar return. That one time nature posed a brutal challenge. How can you prove a phenomenon exists when it never repeats? How do you separate evidence of intelligence from a natural but rare cosmic occurrence when you have only a single data point? Over the decades, dozens of explanations emerged. Some astronomers speculated it could have been a type of neutron star producing an unusual burst, or a hydrogen cloud stimulated by an energetic cosmic event. Others leaned toward more exotic scenarios involving black holes or interactions in dense stellar environments. A highly controversial suggestion came in 2012 from Antonio Paris, who proposed that the signal might have been generated by hydrogen clouds surrounding comets. 2 particular comets, Christensen and Gibbs, happened to be in the general vicinity at the time. If their hydrogen envelopes were illuminated by solar radiation, they might emit at the hydrogen line. The reaction from the SETI community was swift and critical. Observers pointed out that comets drift rapidly across the sky, while the WOW signal appeared stationary. The extraordinary brightness and sharp frequency profile also did not match anything known from comets, and importantly, no other comet before or since has ever produced anything comparable when studied with radio telescopes. The comet theory, while clever, failed to fit the observed facts. This back and forth underscored a central principle of SETI: the burden of proof is enormous. For a signal to be considered evidence of intelligence, it must resist all conventional explanations and display hallmarks that point clearly toward design. The WOW burst certainly met the first requirement. It stubbornly defied natural explanations, but the second remained elusive. Without repetition, structure, or modulation, it remained anomalous rather than unmistakably artificial. In the last few years, new attempts to squeeze information from old archives have shed fresh light. Using modern processing, researchers reanalyzed Big Ear's raw data, narrowing the potential coordinates, and reinforcing just how powerful the signal really was, possibly peaking at intensities 30 times brighter than typical background noise. They eliminated many categories of terrestrial interference, strengthening the case that it came from the sky itself. Some analyses even found hints that the event might fit with a rare natural process known as a hydrogen maser. Maser action occurs when clouds of gas are energized by surrounding events, amplifying radio waves in a way similar to a laser, but at microwave frequencies. Hydrogen masers are uncommon but not unheard of. They've been detected in stellar nurseries and near dying stars. A transient maser triggered by something like a magnetar flare or a passing shock wave could in principle generate a strong narrow signal right on the hydrogen line. This explanation has gained traction among many astronomers, though it does not close the case entirely. And here lies the paradox. Even if the WOW signal was a purely natural maser, its implications remain profound. It would mean we caught a fleeting, one-time phenomenon so rare that decades of searching have yet to find another like it. It reminds us that the universe is still capable of surprising us in ways that leave even seasoned astronomers astonished. But if it was not natural, If it was truly what some have long suspected, then August 15th, 1977, may have been the night humanity brushed against a deliberate message, one that came and went before we were ready to understand it. Imagine this. A strange signal bursts through the static of the cosmos. It's so precise, so perfectly placed, that it makes scientists stop in their tracks. If the famous WOW signal really was just a natural hydrogen flare, it was unlike anything we've ever recorded. The way it matched the exact frequency SETI researchers had always considered the smartest place for aliens to announce themselves, that stretched coincidence beyond breaking, and that's why its legacy still echoes today. That single moment proved that our telescopes, even back then, could catch something powerful from light years away. It showed that our strategies for listening to the stars weren't just theory, they worked. It lit a fire under researchers, inspiring them to keep searching with more dedication than ever. Most importantly, it gave us a blueprint, a benchmark for what credible evidence should look like when hunting for intelligence beyond Earth. And that benchmark still shapes how we judge mysterious signals to this very day. Which brings us to something even more intriguing. Our modern interstellar visitor, known as 3I Atlas. Some wonder if its arrival might connect back, in some cosmic way, to that legendary transmission from 4 decades ago. To understand why people even make that connection, we have to dive into the heart of what made the WOW signal so special, the hydrogen line. Across the vast radio spectrum, every frequency is like a page in the universe's diary. Each one tells its own story, but there's a single frequency that stands apart, almost like the universal bookmark. At exactly 1420.40575 MHz, something tiny yet profound happens in the quantum world. Hydrogen atoms, the simplest, most abundant element in existence, undergo what's called a spin-flip transition. Basically, the lone electron orbiting a hydrogen nucleus flips its magnetic alignment compared to the proton, and when that happens, it releases a tiny, precise packet of energy in the form of radio waves. It's an event so rare that for any one atom, it happens only once every 11 million years. But space is filled with hydrogen clouds stretching for light years, made up of unthinkable numbers of atoms. Together, they create a steady hum of 21-centimeter radiation. It's like the background music of the universe, played on the most fundamental instrument imaginable, the element that builds stars, planets, and even us. What makes this frequency extraordinary is more than its beauty. It's its inevitability. Any civilization that figures out radio astronomy will discover it. They'll measure it, study it, and realize instantly that it's special. Unlike culture, languages, or biology, which differ from planet to planet, this is universal, a constant, a cosmic landmark that no species, no matter how alien, could miss. Early SETI pioneers recognized this as a kind of revelation. In 1959, Giuseppe Cocconi and Philip Morrison published a groundbreaking paper that became the foundation of modern SETI. They argued that if anyone wanted to send a message across the stars, this frequency was the obvious choice, because no matter who's out there, they'd all be listening here. This wavelength also sits in what's called the waterhole. Think of it as a quiet channel in the noisy radio spectrum, bracketed by hydrogen at 1420 MHz, and hydroxyl molecules, around 1660 MHz. Between them, cosmic static drops to unusually low levels, almost like a natural radio sanctuary. The symbolism is striking. Hydrogen and hydroxyl combine to form water, the one ingredient life everywhere might depend on. Just as living creatures gather around watering holes on Earth to connect and survive, maybe advanced civilizations would also gather here, using this natural quiet channel to send messages. And the practical advantages are undeniable. The 21 centimeters wavelength can travel across interstellar distances without being blocked by dust and gas. It requires relatively little energy to transmit, and its narrow band makes it easy to detect. Many governments even protect this frequency from human interference, making sure it stays clear for astronomical research. So when the WOW signal appeared at 1420.455 MHz, just a hair's breadth away from the pure hydrogen line, researchers couldn't help but feel a shiver. This was exactly what theory predicted they should find. A narrow, strong, deliberate-looking signal, parked at the most logical calling card in the cosmos. But that excitement came with a twist. Nature itself also plays tricks here. Hydrogen masers, basically natural cosmic lasers made from gas clouds, can create intense narrowband emissions at this same frequency. Star-forming regions often produce them, So do supernova remnants, where shockwaves ignite nearby gas. Even exotic events like magnetoflares or black holes tearing apart stars could theoretically spark short-lived maser signals. This creates what researchers call the natural mimicry problem. The very frequency most likely used for artificial messages is also where the universe can fake them best. It's like the cosmic version of crying wolf. That's why modern SETI methods don't just look for strength or placement anymore. They search for traits nature can't easily imitate, like signals carrying structured patterns, complex modulations, or frequency drifts that account for motion. They also look for repeatability. A true artificial beacon might reappear at the same location, proving it wasn't just a one-off cosmic accident. Over time, the waterhole idea has expanded too. Researchers now explore other biologically meaningful frequencies, such as the ammonia line at 23 GHz, certain organic compounds, and even parts of the microwave background that are especially quiet. Still, the hydrogen line holds its crown. Projects like Breakthrough Listen devote huge amounts of time to it. China's FAST telescope routinely scans it during SETI runs. Even optical SETI experiments sometimes sync laser searches to hydrogen-related wavelengths. And if we, as humanity, ever choose to broadcast a deliberate message to the stars, many scientists argue the hydrogen line would be the most obvious place to plant our flag. It's universal, unavoidable, and unmistakable. What makes all this even more thrilling is how far technology has come since the WOW signal. Today's instruments can split signals down to separations of just a few hertz. They can detect polarization that reveals hidden details about distant magnetic fields. Most importantly, they can process data in real time, allowing immediate follow-up instead of waiting weeks to discover something after it's already faded. Which means that if another WOW signal were to appear today, we'd be ready in ways that the astronomers of 1977 could only dream of. Picture this. A visitor from beyond our solar system drifts through the vastness of space, cutting across the planetary neighborhood we call home. Its name is 3I Atlas, a traveler older than Earth itself, a messenger that has crossed interstellar distances before our species ever lit its first fire. Now imagine for a moment that this wanderer isn't just a stray rock carried by gravity's current. What if its journey is somehow tied to one of the most famous cosmic mysteries of all time, the WOW signal? That strange, unforgettable burst of energy that arrived nearly half a century ago, whispering through the static at the one frequency where countless scientists believed an alien message would most likely appear. If both Atlas and the WOW signal represent parts of some larger puzzle, then the stakes are far higher than we realize. The very moments when Atlas sweeps closest to major worlds, Mars, Earth, and even the Sun, become more than astronomical milestones. They become opportunities, the optimal windows to listen, with every radio telescope on the planet tuned to the exact channel that captured the WOW signal in 1977. And what's remarkable is that this frequency is not random, not arbitrary. It is carefully chosen by the universe itself. The hydrogen line, a universal marker, carved into the structure of reality, that any advanced civilization would recognize instantly. When telescopes today listen in as Atlas approaches Earth, they are not just scanning background noise. They are eavesdropping on the most logical conversation starter the cosmos could ever provide. Whether they catch a whisper of something extraordinary, or record only silence, the act itself is profound. It shows humanity's stubborn commitment to possibility, to the belief that we might not be alone, and to the idea that messages can be written in the very language of the universe. But this optimism is tangled with a deeper problem, one that has haunted the WOW signal for nearly 50 years. Reproducibility. In science, nothing matters more. A discovery that cannot be repeated is a discovery that cannot be trusted. Without replication, even the most exciting event is downgraded from revelation to rumor, and that is exactly where the WOW signal has lived since that August night in 1977. Too important to dismiss, too isolated to accept, caught in a purgatory where skepticism and hope wrestle endlessly. The search for answers began almost immediately. Within weeks of astronomer Jerry Eman circling that mysterious spike with his red pen, telescopes worldwide were pivoting toward the constellation Sagittarius, the patch of sky where the signal had appeared. The Big Ear team themselves scanned obsessively throughout the late 70s and into the 80s. Nothing. Silence. Then the Very Large Array in New Mexico joined in, with its sprawling dishes and sharp sensitivity. It brought new power to the hunt. Still, nothing. Arecibo, with its enormous dish capable of detecting whispers far fainter than Big Ear could ever hear, combed the same region methodically. The Parkes Observatory in Australia added southern hemisphere coverage, expanding the global net. International collaborations sprang up like never before, pooling resources and hours of telescope time. Everyone was trying to trap lightning in a bottle, and still the cosmos gave them nothing back. Decades passed. The technology leapt forward. Digital receivers replaced the clunky analog systems of the 70s, allowing astronomers to sift through massive streams of data with far greater precision. Sophisticated algorithms began flagging anomalies that human eyes might have missed. Computers could store and reprocess entire swaths of the sky, and yet, even with all these upgrades, the wow signal refused to reappear. No matter how sensitive the ears, no matter how persistent the listening, the signal remained a solitary enigma. This one-time burst became both its greatest weakness and its greatest allure. Astronomy thrives on patterns. Pulsars pulse with steady precision. Variable stars brighten and dim like celestial heartbeats. Even the wildest events, the explosions of supernovae, the violent flares of magnetars, the sudden crackle of fast radio bursts, repeat in some form, either through recurring bursts or identifiable sources. But the wow signal defied all that. It stood alone, no recurrence, no pattern, just one impossible flare of energy, never seen again. By the early 2000s, the tide began shifting toward dismissal. Some researchers argued that it was probably an instrumental glitch. The Big Ear, after all, was aging even then. Its electronics might have burped at the worst possible moment, creating the illusion of something profound. Others speculated about more mundane culprits. Maybe a passing aircraft reflecting radio signals in just the right way. Maybe a stray transmission from Earth bouncing off the atmosphere. Maybe even something as absurd as a microwave oven leaking radiation. The wow signal, they claimed, was not cosmic at all, but local, a ghost of our own technology, mistaken for an interstellar greeting. But then came the reanalyses of 2024 and 2025, and suddenly the story shifted again. A team led by the National Radio Astronomy Observatory decided to revisit the original Big Ear data, armed with modern tools that the astronomers of 1977 could only dream about. They dug deep, pulling subtle details out of the archives that had been invisible for decades. And what they found was stunning. First, they pinned down the signal's likely origin with far greater accuracy. By carefully studying the way the intensity rose and fell as the Big Ear's twin beams swept across the sky, they narrowed the possible source region to just 8 arc-minutes across. To put that in perspective, that's a patch of sky barely a quarter the width of the full moon. This level of precision instantly ruled out many terrestrial interference scenarios. It strongly suggested that the source was not local, not atmospheric, but out there in space. A genuine point source somewhere among the stars. Second, they confirmed just how powerful the signal really was. Earlier estimates had been conservative, but the reanalysis showed that its peak intensity may have exceeded 250 Janskys. That makes it one of the strongest narrowband signals ever detected from beyond the solar system. For comparison, the Crab pulsar, one of the brightest known radio sources in the Milky Way, would appear 50 times weaker at the same frequency. This wasn't just a faint whisper, it was a shout. But perhaps most tantalizing of all, the researchers found hidden patterns in the surrounding data, subtle enhancements, faint traces at nearby frequencies and times, like echoes rippling around the main spike. These patterns suggested that the wow signal might not have been a simple, clean burst. It might have been part of a more complex emission, something evolving rapidly in time and frequency, something that looked eerily similar to a hydrogen maser caught in the act of firing. This maser hypothesis quickly rose to the top of natural explanations. A maser, short for microwave amplification by stimulated emission of radiation, is essentially the radio wave version of a laser. Under the right conditions, clouds of interstellar gas can become population inverted, meaning their atoms are primed to release energy all at once, creating a powerful narrow beam of radio waves. Hydrogen masers are rare but not unheard of. They've been observed in star-forming regions, where collapsing gas clouds ignite new suns, and around elderly stars shedding their outer layers. In theory, an energetic event, maybe a magnetoflare, maybe a shockwave from a distant supernova, maybe even a gamma-ray burst in another galaxy, could excite a hydrogen cloud just right, triggering a temporary maser that flares for minutes or hours before vanishing forever. This neatly explains several things. The wow Signal's perfect match to the hydrogen line? Check. Its narrow bandwidth? Check. Its extraordinary strength? Maser amplification can easily account for that. Its frustrating uniqueness? That too, because once the conditions fade, the maser is gone, never to repeat. But even this explanation, while elegant, raises unsettling questions. For one, no hydrogen maser of that kind has ever been observed before or since. If the WOW signal really was such an event, then astronomers in 1977 just happened to be listening at the exact right place, at the exact right time, to catch a phenomenon the universe almost never produces. That level of coincidence is hard to swallow. Even stranger, such an energetic trigger should have left other fingerprints, X-ray flashes, gamma-ray bursts, optical transients. Yet no other observatory, in any other wavelength, recorded anything unusual in that patch of sky around August 1977. This is what keeps the debate alive. On one hand, the maser idea is the most plausible natural explanation we have. On the other hand, it still feels like it stretches coincidence to breaking, almost as if the universe went out of its way to fool us. Which brings us full circle. If a natural signal can look this artificial, and if an artificial signal can be dismissed as natural, how can we ever be certain? History has shown this problem again and again. When pulsars were first discovered, their perfect regularity was so uncanny that astronomers jokingly labeled them LGM, little green men. When fast radio bursts first appeared, their strange dispersion patterns led some to speculate they might be alien beacons. Each time nature proved capable of producing phenomena far stranger than we'd imagined. The WOW signal lives right on that knife's edge, not definitively natural, not definitively artificial, a mystery balanced between the two. And that's why its connection to 3I Atlas captures so much imagination. Here we are, nearly 50 years later, still haunted by a single unrepeatable signal, and now an interstellar object passes through the very region of sky linked to that event. Coincidence? Perhaps, or perhaps not. Maybe the WOW signal wasn't a glitch or a maser. Maybe it was a beacon, a breadcrumb left for civilizations bold enough to follow. Maybe Atlas is the next breadcrumb, a different kind of signal, written not in radio waves, but in motion. A visitor whose very path is a message. What we choose to believe depends on how open we are to possibility. But one thing is certain, as long as telescopes continue to listen, as long as humanity keeps pointing its ears to the hydrogen line and beyond, the WOW signal will never truly fade. It will remain the question that refuses to be answered. A single word, scribbled across the silence of space. Wow. Imagine this. A telescope detects a powerful, precise signal coming from deep space. It flares once, sharp and unforgettable, then never repeats. Was it a cosmic accident, a trick of nature, or the only hello humanity will ever receive from another civilization? That haunting uncertainty has echoed across decades. And now, as a mysterious interstellar visitor crosses our skies, the question grows sharper than ever. Are we staring at two separate enigmas, or witnessing fragments of a single larger story unfolding in real time? The refusal of that famous signal to repeat doesn't automatically mean it wasn't artificial. Entire worlds and stars have finite lifespans. An advanced society may have broadcast once, only to vanish in disaster, a collapsing star, a destroyed planet, or perhaps simply shifting their attention elsewhere. Likewise, the fact that the transmission appeared at the hydrogen line doesn't prove it came from intelligence. The universe has a knack for producing natural imitations of exactly the kind of narrowband, structured emissions we expect to find. That tension leaves us in a state of ambiguity, frustrating on one hand, yet deeply productive on the other, because it's often in uncertainty where real scientific progress begins. The WOW signal, as it came to be known, forced astronomers to refine their methods. They built sharper algorithms, honed instruments, and designed surveys capable of ruling out mundane explanations. It confirmed that our technology could pick up extraordinarily strong transmissions across interstellar distances. More importantly, it set the bar for what constitutes credible evidence in the search for extraterrestrial intelligence. Those standards continue to guide how scientists evaluate strange detections today, which brings us to a new mystery. Unlike a fleeting burst of radio waves that vanishes without a trace, the object nicknamed Atlas offers a tangible opportunity. It can be observed repeatedly, tracked across the heavens, and even studied for chemical composition. It provides the rare chance to test, probe and verify possibilities that radio alone could never grant. And so the same question that haunted SETI in the late 1970s still lingers. Are these two curiosities unrelated accidents, or do they form two halves of something greater? The possibility that they connect, even loosely, keeps researchers awake at night. To follow this trail, we need to understand why the direction of Sagittarius matters. Ancient skywatchers saw a centaur drawing his bow in that constellation, unaware that his arrow pointed toward the most extraordinary environment in our galaxy. When you gaze at Sagittarius, you're not just looking at scattered dots projected on the sky, you're staring straight into the Milky Way's beating heart. Roughly 26,000 light-years away, buried behind thick curtains of interstellar dust, lies a gravitational monster, a supermassive black hole weighing over 4 million times the mass of our Sun. This dark engine holds our galaxy together, binding billions of stars into their vast spiral dance, while occasionally tearing apart anything unlucky enough to wander near its horizon. Surrounding this black hole is a neighborhood unlike anything in our local patch of space. Star clusters crowd so tightly that stable planetary orbits would be constantly disrupted. Radiation levels, there are fierce enough to strip atmospheres bare. Magnetic fields writhe and snap with energies dwarfing anything near Earth. To a radio astronomer, this environment is both paradise and nightmare. The galactic center spews more radio emission than any other direction. Pulsars, supernova remnants, nebulae, and mysterious phenomena we barely comprehend all overlap in chaotic abundance. It's the ultimate cosmic cocktail party, where countless voices shout at once, making it agonizingly difficult to pick out any single speaker. When Carl Jansky first stumbled upon cosmic radio waves in 1932, the loudest source he detected came from this very region. Since then, every known type of radio emitter has been catalogued here in overwhelming numbers. For SETI, this presents a paradox. On the one hand, if a civilization wanted to broadcast across the galaxy, this central hub would be perfect. Thousands of stars sit packed into tight regions where a single signal could blanket countless worlds. On the other, the natural interference is staggering. Trying to find an artificial beacon in this storm of emissions is like trying to catch a whisper in the middle of a roaring stadium. That's what made the WOW signal so remarkable. Against this backdrop of chaos, it shone with unusual clarity. Its razor-thin bandwidth and perfectly tuned frequency hinted at an origin far more deliberate than most natural phenomena. Some compared it to a maser, an astrophysical cousin to the laser, while others leaned toward the possibility of intelligent engineering. Either way, its presence in such a hostile radio environment was startling. The constellation of Sagittarius sprawls across about 30 degrees of sky, wide enough to fit 60 full moons side by side. That vast area means that when we say both the WOW signal and the interstellar object Atlas trace back to Sagittarius, it could still represent coincidence. After all, such a large swath includes some of the busiest astrophysical real estate in the Milky Way. Yet, precision matters. In recent years, astronomers narrowed the WOW signal's origin to within just 8 arc-minutes, a sliver of sky that places it in the same general neighborhood from which Atlas seems to approach. Coincidence? Perhaps. But coincidences of this nature are exactly the kind that grab astronomers' attention and refuse to let go. Objects traveling from that direction endure a brutal journey. To arrive at our solar system from Sagittarius, they must thread their way through extreme regions. Gravitational distortions tug at their paths, radiation bombards their surfaces, altering chemistry, magnetic fields twist around them, influencing charged particles and sometimes even trajectories. If Atlas truly came from that corridor, its survival alone speaks volumes. What's more, its chemistry stands apart from typical comets we know. High concentrations of carbon dioxide compared to water, combined with the strange presence of nickel, without the usual companion ion, point to formation conditions unlike those of our solar system. Perhaps it was born around a very different kind of star. Perhaps it spent eons drifting through galactic neighborhoods our local comets never experienced. This deepens the puzzle. Sagittarius isn't just a direction, it's a clue wrapped in layers of astrophysics, demographics, and cosmic strategy. If intelligent life does exist elsewhere, long-lived stable stars with rich chemical inventories would be natural birthplaces. And where are many of those stars located? Exactly in regions like those toward the galactic core. That means both the signal and the visitor trace back to not just a random patch of sky, but to one of the most promising, if challenging, neighborhoods for life to emerge and thrive. The galactic core, despite its violent energy fields and hostile radiation, is home to some of the oldest and most element-rich star clusters in existence. From a communication strategy standpoint, it's hard to imagine a more advantageous place for transmitting across the galaxy. A transmitter positioned anywhere in this dense bulge could send signals rippling through enormous stretches of the Milky Way, reaching thousands upon thousands of planetary systems in a single broadcast. It's the celestial equivalent of building a transmitter at the summit of the tallest mountain, where the entire horizon lies open. That simple logic explains why so much of SETI's early focus targeted both the center of the galaxy and the hydrogen line, a frequency long regarded as nature's universal hailing channel. Visionaries in the field reasoned that if any society wanted to maximize efficiency while minimizing energy waste, they would establish their communication hub in the heart of the Milky Way and use the quietest, most recognizable channels nature provides. Today, new surveys are on the verge of showing us just how much traffic moves through interstellar space. The upcoming Legacy Survey of Space and Time will soon reveal hundreds, maybe thousands of wanderers slipping through our cosmic neighborhood, turning what now feels like rare discovery into a predictable population. Right now we've spotted only 3 confirmed visitors from the void, but that small number will soon grow into a massive dataset. Most of these nomads will arrive from random patches of sky, each carrying the chaotic imprint of ejection from long-forgotten planetary systems billions of years ago. But if Atlas truly proves unique, if its structure, chemistry, or behavior stands apart, then the fact that it comes to us from Sagittarius gains sharper weight. When multiple anomalies converge in both direction and timing, pure coincidence becomes harder to accept. Sagittarius has already given us 2 enduring riddles: a vanishing radio pulse unlike anything else detected, and now a strange comet-like traveler bearing chemical fingerprints that defy our expectations. Whether these represent an interconnected narrative or simply chance overlap, they remind us of something profound. The galaxy may not be the quiet, lonely wilderness we once imagined. Instead, it could be active, restless, and far more entangled than our limited perspective suggests. Atlas now moves steadily inward, crossing the orbits of Mars before arcing closer to our star. Each mile it travels presents us with fresh opportunity. Telescopes can watch for faint emissions near the hydrogen frequency, hoping to catch even the faintest whisper of an artificial beacon. If signals appear precisely as the object drifts past our planetary neighborhood, the overlap would be impossible to dismiss as random. Yet silence itself would still matter, because silence, when studied closely, teaches us what isn't happening, narrowing possibilities, refining models, and reshaping our search strategies. Either way, Sagittarius has forced us into humility. It shows us a universe brimming with mysteries beyond easy explanation, phenomena that demand we stretch our imaginations without slipping into unfounded certainty. That humility sharpened again, on July 1st, 2025. As most of humanity slept, an automated system in Chile scanned the heavens from its perch in the Atacama Desert. Night after night, its sensitive cameras swept the skies, cataloging potential threats from wandering asteroids. This program, known as ATLAS, short for Asteroid Terrestrial Impact Last Alert System, had become routine in its vigilance. But on that particular morning, something unusual appeared on its frames. Against the backdrop of fixed stars, a moving point darted with a speed too unusual to belong to familiar solar system bodies. Within moments, the system's algorithms flagged it as extraordinary. Its track screamed outsider. The curve of its motion revealed a hyperbolic path, meaning it was not bound to our sun, but only passing through, bent temporarily by gravity before slipping away forever into interstellar darkness. John Tunnery, the lead investigator for ATLAS, recognized at once the importance of what had been spotted. Initial orbital solutions showed an eccentricity greater than 1.0, the unmistakable signature of a visitor from beyond. This was no asteroid wandering off course, no long-period comet circling back from the Oort cloud. This was something alien to our system, something born elsewhere, and destined to leave as quickly as it arrived. The object was designated 3I Atlas, joining a tiny but growing list of interstellar wanderers. Unlike Oumuamua, which astronomers detected only after it had swung around the sun and was racing back into the void, Atlas was caught while still inbound. That timing created a golden opportunity, months of observation before it escaped our reach. Telescopes worldwide rushed to lock onto its track, hungry for every photon it reflected. The race was on, and every day counted. Early data showed an object with behavior both familiar and perplexing. As it approached the warmth of the inner system, solar radiation stirred frozen compounds within its heart. Gas and dust began streaming outward, surrounding the body with a glowing atmosphere, followed by the birth of a tail, classic cometary signs. but appearances were deceiving. When scientists split its light into spectra, the readings shocked them. The James Webb Space Telescope, with its unmatched infrared sensitivity, detected carbon dioxide at levels nearly 8 times greater than water vapor. In our system, comets usually show the reverse pattern. Water dominates, with carbon dioxide as a minor trace. Yet here was a body that seemed built on entirely different priorities. The Hubble Space Telescope contributed key size measurements. Sharp imaging suggested a nucleus no larger than 5.6 kilometers across, and possibly as small as just 320 meters. If the smaller end of the range proved true, the body was punching far above its weight. Astronomers used the word overperforming to describe how such a small nucleus could produce such a large and active coma. Ground-based facilities layered more detail onto the puzzle. Gemini South in Chile captured striking photographs of the coma and tail, tracking their growth as Atlas approached the Sun. Meanwhile, the Very Large Telescope conducted high-resolution spectroscopy and discovered nickel lines in the spectrum. That in itself wasn't strange. Nickel emissions are fairly common in cometary activity. But here came the twist. While nickel appeared clearly, iron did not. In cosmic environments, nickel and iron nearly always walk hand in hand. Their similar chemical histories and bonding properties make them almost inseparable companions. Yet Atlas displayed an imbalance, giving off nickel but hiding iron to the limits of detection. The anomaly sparked debate across the field, with some suggesting exotic formation conditions and others arguing we might be missing something fundamental about how materials release under intense radiation. Its orbit only deepened the intrigue. Atlas was inbound on what astronomers call a retrograde track. Instead of circling the Sun in the same direction as planets and most solar system debris, it came the opposite way, like a vehicle moving against traffic on a one-lane highway. Yet, despite this reversal, its inclination, about 5 degrees relative to the planetary plane, kept it roughly aligned with our system's geometry, a strange symmetry, moving with us in space but against us in motion. As summer advanced, activity intensified. By August, water began streaming in vast plumes, expanding the coma into a cloud visible even through medium-sized amateur telescopes. Each week brought fresh changes. The object seemed alive, constantly reshaping under the Sun's relentless pressure. For astronomers, it was a spectacle unlike anything they had tracked before, a messenger from beyond, both familiar and alien, performing under the harsh spotlight of our star. Imagine staring into the night sky, expecting a faint smudge of light, only to realize that what you're looking at isn't just another comet, it's a traveler from a completely different star system. Over months, astronomers tracked this mysterious object as sunlight sculpted its tail into a graceful arc, the kind of pattern that has stirred human curiosity since the dawn of history. Yet, despite its striking shape, this cosmic visitor remained frustratingly dim. Its maximum brightness, predicted to hover around magnitude 11 to 13, placed it well out of reach for the naked eye. Only large advanced telescopes could bring its details into view, unlike legends such as Hale-Bopp or Hyakutake, which once captured public imagination. This meant that only professionals and the most dedicated amateur astronomers would truly experience its presence. As excitement spread, so did concerns. People everywhere wondered, could this thing collide with Earth? Agencies wasted no time answering. NASA and its counterparts quickly calculated the orbital path and assured everyone the object posed no risk. Its closest approach would come in mid-December 2025, but even then, it would stay at a safe distance, about 270 million kilometers away, nearly double the Earth-Sun gap. So, while dramatic headlines filled social media, the experts made it clear this wanderer was no threat. Still, its discovery was monumental. This wasn't just another comet. It was the third confirmed interstellar object to ever pass through our solar system. The first, the Furumomo, in 2017, had confounded scientists with its bizarre cigar-like shape and unexplained acceleration. 2 years later, 2I/Borisov appeared, resembling a more typical comet, but carrying the chemical fingerprints of a world beyond our own. Now came 3I/Atlas, bringing with it the promise of something different. Unlike its predecessors, this one was spotted early enough to give astronomers months of preparation. Every telescope on Earth and in orbit could now aim at it, capturing data from every possible angle. For scientists, this was like being handed a time capsule from another star, a sample of material forged light years away. Each spectrum, every image, each measurement carried the potential to reshape our understanding of how planets and systems form across the galaxy. But then came a coincidence that was impossible to ignore. Its path through the sky pointed toward the same region where, nearly half a century earlier, a mysterious radio transmission had once been picked up, the famous WOW signal. Both the comet's arrival and that enigmatic burst of radio noise traced back towards Sagittarius, the bustling core of the Milky Way, where stars crowd together in unimaginable numbers. Astronomers quickly cautioned against drawing connections. The region of Sagittarius is vast, covering an enormous stretch of sky. But even as observatories across the world launched into their intensive monitoring campaigns, the question buzzed quietly in the background: was this object merely a random fragment flung from some distant solar nursery, or was its timing and direction something more deliberate? Was this chance, or was it a message? That question only grew louder as new data poured in during the summer of 2025. The more scientists looked, the stranger this visitor became. Observations from the James Webb Space Telescope delivered the first shock. Instead of a coma dominated by water vapor, as is common in nearly every comet of our own solar system, 3I/Atlas showed something completely different. Its atmosphere brimmed with carbon dioxide, so much in fact that CO2's levels overwhelmed water vapor by nearly 8 to 1. Normally, water is 10 times more abundant than carbon dioxide in comets born around our sun. Here the ratio was reversed. This upside-down chemistry suggested that the comet had formed in an environment nothing like ours, possibly around a hotter star, or in a region with vastly different raw ingredients. Suddenly, this wasn't just a visitor, it was a messenger carrying a chemical fingerprint from an alien system. And the mysteries didn't stop there. Despite its modest size, Hubble's measurements suggested a nucleus no larger than about 5 or 6 kilometers across, maybe even smaller. It behaved like a giant. Its activity levels rivaled much larger comets. The coma ballooned outward to span hundreds of thousands of kilometers, and the tail stretched millions of kilometers into space, glowing with an intensity that didn't match its scale. This dramatic overperformance stunned comet specialists. Normally, small bodies lack the energy and internal reserves to release so much gas and dust. They simply don't have enough surface area to absorb sunlight, or enough volatile materials to keep venting. Yet 3I/Atlas seemed to break the rules, unleashing material as if its tiny frame were somehow engineered for efficiency. Then came another anomaly that deepened the puzzle. Using the Very Large Telescope in Chile, astronomers broke down the light coming from the coma. What they found seemed almost designed to raise eyebrows. The spectrum revealed strong emissions from nickel, metal atoms glowing as they were vaporized by sunlight. That part wasn't surprising. Nickel shows up frequently in cometary spectra, but iron, which nearly always accompanies nickel in cosmic environments, was conspicuously missing. Normally the two metals appear hand in hand, bound together in the same mineral mixtures. Yet here was nickel blazing bright while iron lines remained invisible, below detection limits. The scientific community scrambled for explanations. Some argued that the iron might still be present, locked into compounds that required far higher temperatures to vaporize. If so, perhaps the missing lines would reveal themselves later, as the comet drew nearer to the sun. Others suggested that 3I/Atlas was simply built differently, forged in a system where nickel-rich minerals dominated while iron was scarce. If that were true, then this object carried within it a fingerprint of a star system, utterly unlike our own. Piece by piece, a picture was forming that refused to align with ordinary expectations. This wasn't just a faint dot crossing the night sky, it was a riddle written in chemistry, in brightness, in structure. And while the official stance remained cautious, a natural object with unusual traits, the coincidences piled up, and the silence between the data seemed almost as loud as the discoveries themselves. Observers couldn't help but wonder, was this comet merely another fragment of cosmic debris, or was its timing and its oddities part of something much larger, something we were only beginning to glimpse? The way this interstellar visitor moved through space only deepened the mystery. Unlike most bodies we track in the solar system, this object wasn't drifting along with the familiar planetary traffic. Instead, it came barreling in on a retrograde path, cutting across the system in the opposite direction. Its orbital tilt was a mere 5 degrees relative to the plane of the planets, meaning it was nearly coplanar with our solar family, but racing against the flow. While retrograde motion does occasionally appear in nature, it's rare, especially for material believed to have been ejected from other planetary systems. Statistically, one would expect random orientations, scattered directions, not something so neatly aligned with our own celestial architecture. The odds of an interstellar object arriving nearly flush with the ecliptic, yet moving backwards, added yet another layer to a growing string of peculiarities. As the weeks rolled into late summer, the comet grew brighter and more active. What struck observers was not just its growing luminosity, but the timing of its behavior. Long before it neared the warmer inner regions of the solar system, it had already erupted into a frenzy of activity. By the time it was still more than 3 astronomical units from the Sun, far beyond where icy bodies normally begin venting gas and dust, it had unleashed a coma and tail as if it were much closer. In our own system, comets usually remain dormant until proximity to solar heat stirs them awake. But this traveler broke tradition, igniting prematurely. That early burst hinted at either a chemistry packed with highly volatile compounds or an unusual sensitivity to even faint sunlight. Inevitably, such anomalies drew the attention of researchers who dwell on possibilities beyond the ordinary. One of the most vocal voices was R.V. Loeb of Harvard University, already well known for his controversial claim that Oumuamua might have been some form of alien technology. Loeb examined Atlas with equal interest, highlighting features that, in his view, might align with artificial rather than natural origins. He pointed to the overwhelming presence of carbon dioxide, which could be interpreted, if one stretched imagination toward the speculative side, as a potential byproduct of industrial processes, rather than simple primordial ice. He also noted the odd nickel emissions, which could suggest refined or engineered materials with specific metallurgical characteristics, something difficult to reconcile with natural cometary chemistry. Of course, such ideas ignited debate. The majority of astronomers countered with caution, emphasizing that anomalies don't automatically translate to technology. Jason Wright of Penn State, among others, reminded the community that extraordinary claims demand extraordinary proof. From their perspective, 3I/Atlas still behaved like a comet in many fundamental ways. It sprouted a coma and tail, responded predictably to solar energy, and obeyed the laws of gravity, without deviation. Its trajectory showed no sign of deliberate course corrections or controlled maneuvers. Even its puzzling chemistry, though unusual, could be attributed to conditions in a star system unlike our own, rather than deliberate construction. Yet even skeptics acknowledged that this was not business as usual. The combination of traits, retrograde motion, compact size paired with immense activity, bizarre chemistry, and its arrival from the same general part of the sky as that half-century-old radio mystery, painted a picture that felt at the very least uncanny. Each feature by itself might have been shrugged off as an outlier, but stacked together, they created a narrative too suggestive to dismiss outright. By the time autumn of 2025 approached, and the comet neared critical points in its path, including a close interaction with Mars, and eventually a tightening loop around the Sun, the question hung unresolved. Was this simply a comet unlike any we had seen, born under strange conditions that defied our expectations, or was it something more deliberate, a technological artifact disguised in the familiar trappings of ice and dust? And just when the speculation seemed to reach its peak, another connection pulled focus back to a familiar cosmic landmark, Sagittarius. In astronomy, patterns are fragile things. 2 points of data can feel like destiny, even when logic says it's coincidence. Yet, when the latest trajectory analysis confirmed what early hints had suggested, that this object had indeed approached from the general direction of Sagittarius, the echoes of the WOW signal resurfaced. The object's radiant, the precise point from which it appeared to enter our skies, fell within the same swath of stars where that mysterious radio pulse had been detected decades earlier. It wasn't a perfect overlap. The uncertainties of measurement left wiggle room. Still, it was close enough for scientists to classify the connection as a positional coincidence. Understanding the weight of that coincidence requires scale. Sagittarius spans about 30 degrees of sky, which translates to the apparent size of around 600 full moons lined side by side. Within that enormous patch, the WOW signal's refined location covers a tiny region, only a handful of arc-minutes across. The radiant of 3/Atlas sits a few degrees away, its uncertainty ellipse overlapping just enough to catch attention, but not so precise as to prove anything. From a statistical standpoint, finding 2 anomalies within such a wide constellation isn't shocking. Sagittarius occupies nearly 1/15 of the entire celestial sphere. By probability alone, around 7% of unusual astronomical events should appear there. 2 data points simply aren't enough to declare a pattern. But the problem is, Sagittarius isn't just any random piece of sky. It's our direct line of sight into the galactic center, the bustling heart of the Milky Way, where stars are crammed together at densities unimaginable compared to our quiet neighborhood. In that environment, countless planetary systems could orbit within close quarters, some perhaps stable, others disrupted by powerful gravitational tides. For any advanced species, such a region would be both perilous and full of opportunity. Survival there might demand remarkable technological sophistication. At the same time, its central location makes it an ideal hub for broadcasting across the galaxy. From a communication strategy perspective, the galactic core is the ultimate vantage point. One transmitter there could blanket the Milky Way with signals at minimal energy cost. That's why SETI researchers have long considered Sagittarius prime real estate when searching for alien messages. If civilizations wanted to reach the widest possible audience, the galactic center would be the logical choice. Likewise, any society scouring the heavens for signs of intelligence would naturally prioritize looking toward regions with the greatest concentration of stars and potential habitable worlds. Against that backdrop, seeing both a comet of impossible oddities and a mysterious radio transmission trace back to the same sector feels less like chance and more like an invitation to keep asking questions. The logic that drove early SETI searches still echoes today, shaping where astronomers turn their instruments. The galactic center remains both the most tempting and the most treacherous region for listening. Its packed star fields and constant radiation make it a natural hotspot for strange signals, yet those same conditions bury any potential message beneath a fog of interference. If alien broadcasts existed anywhere, this would be the likeliest place, but separating engineered signals from exotic astrophysics is like trying to hear a whisper in the middle of a storm. What makes the overlap between the WOW signal and 3I/Atlas even more fascinating is not only their shared direction, but also the timing. Imagine the dynamics at play. Countless fragments flung outward from star systems in the galaxy's crowded core. Over millions, perhaps billions of years, these relics drift across interstellar space, some eventually reaching neighborhoods like ours. If Atlas was one such fossil, then its presence here links us directly back to the galaxy's busiest stellar nursery. But the real riddle is when it arrived. The odds are staggering. The universe has existed for 13.8 billion years. Humanity has wielded radio receivers for barely a century and a half. Yet in that sliver of cosmic time, we detect a powerful, unexplained burst from Sagittarius, and decades later, an interstellar body from the same general direction wanders into our system. To argue both are entirely unrelated coincidences feels almost absurd. The chances that two anomalies line up in space and in this fleeting window of time seem vanishingly small. But coincidence can cut both ways. If Atlas were guided, nudged, or even deliberately aimed at our solar system, its arrival in humanity's radio-capable era would make perfect sense. Rather than an accident, it would appear as a response, a marker of connection timed to meet us when we were finally able to notice. That scenario, of course, demands proof beyond anything we currently hold. And so far, Atlas behaves stubbornly like a comet. No propulsion, no controlled course adjustments, no engineered signals. Its spectrum, though bizarre, still fits within the wild diversity that nature is capable of. And yet the discomfort lingers. Two of modern astronomy's strangest puzzles, separated by half a century, both point to Sagittarius, the one patch of sky that represents the galaxy's most extreme environment. Are we chasing shadows, inventing patterns where none exist? Humans are wired to connect dots, even when the picture may not be real, or are these hints part of something larger, a tapestry we've only begun to glimpse? For now, the only honest answer is uncertainty. A few cases never prove a pattern. To know if Atlas is truly unique, or just the tip of a much bigger iceberg, we need volume. That's where the upcoming Legacy Survey of Space and Time comes in. Once the Vera Rubin Observatory begins full operations, it's expected to uncover hundreds, perhaps thousands of new interstellar wanderers. If most resemble Atlas, then it's less anomaly, more archetype. But if it remains a rare outlier, then its strangeness deepens. On the radio side, new instruments keep pushing sensitivity to unprecedented levels. Advances in data processing, signal cleaning, and transient detection mean that bursts once lost in the noise can now be pulled into focus. Should another short-lived transmission emerge from Sagittarius, especially if it coincides with Atlas's passage through our solar system, the claim of coincidence would collapse under its own weight. Until then, we stand in the middle of unanswered questions. Two phenomena, both tied to the same corner of the sky, tease us with the possibility that the galaxy is more alive and more networked than we imagined. maybe it's all chance. Maybe it's the universe reminding us that our perspective is still painfully narrow. Or maybe it's the first faint brushstrokes of a larger picture, one waiting for us to collect enough evidence to see clearly. And while the signal from decades ago remains frozen in history, Atlas itself follows a schedule written by gravity's hand. Its path through our solar system is predictable, precise, a celestial appointment book carved into space. That timeline offers not speculation but opportunity, a chance to probe this visitor with every tool we have. The first appointment is already drawing near. In early October of 2025, Atlas will glide past Mars at just 30 million kilometers. That distance is close enough for the spacecraft already orbiting the red planet to catch it in their sights. The European Space Agency has confirmed that Mars Express and the ExoMars Trace Gas Orbiter will both attempt coordinated observations during the flyby. For the first time in human history, machines we've stationed around another planet will watch an interstellar object up close. This isn't just another observation. Multiple spacecraft will capture Atlas from different perspectives, giving us stereoscopic views that Earth-based telescopes can't provide. That geometry could finally reveal its shape, spin, and even hints of surface texture. The flyby will also allow precise tracking of how Atlas tugs gravitationally on the orbiters, giving us estimates of its mass and internal makeup. The timing is uncanny. The Mars encounter falls almost exactly when Atlas is expected to reach peak activity, flaring with volatile release as solar heating intensifies. Every instrument trained on it during those days will have a front-row seat to its most revealing behavior. Will the strange nickel signature persist? Will iron finally emerge as the temperature climbs? These are the kinds of answers that could reshape our understanding, or deepen the mystery further. From Mars, Atlas will continue plunging inward, drawn toward its closest approach to the Sun. And each stage of that journey marks another step in an unfolding story where coincidence, probability, and possibility collide. The next great milestone arrives at the end of October 2025. On the 29th and 30th, Atlas will swing through perihelion, its closest approach to the Sun, at just 1.4 astronomical units. That's inside Mars's orbit, but still comfortably outside Earth's path. Perihelion is the stress test for any comet. Solar radiation blasts its nucleus at maximum intensity, driving violent sublimation and pushing activity to its limits. If Atlas hides anything unusual, exotic minerals, unexpected internal structures, or even engineered components, this is when the truth would most likely surface. But there's a catch. From Earth, Atlas will sit almost on top of the Sun in our sky, effectively invisible to ground-based telescopes. For weeks it will be lost in solar glare. Only space observatories with protective shielding, like Hubble and the James Webb Space Telescope, will have a chance to keep watch. Time on those instruments is precious, and the competition will be fierce. For the rest of us, the object will disappear into the brightness until early December, when it finally re-emerges, setting the stage for the most anticipated moment of its entire journey. On December 19, 2025, Atlas makes its closest pass to Earth, 270 million kilometers away, about twice the distance between us and the Sun. That may sound far compared to comets that have skimmed near Earth in the past, but it's an ideal sweet spot, close enough for detailed observations, yet distant enough to avoid gravitational complications. More importantly, this window offers a unique opportunity. If Atlas is linked in any way to the legendary WOW signal, this is when we might hear it. The geometry is perfect. Doppler shifts would be minimized, signal strength maximized, and Earth-based radio telescopes would have uninterrupted sky coverage. If there's even a whisper of a transmission, this will be the best time to catch it. The Earth encounter also offers a subtle but powerful test. Natural objects obey gravity with mathematical precision. Any deviation, no matter how small, would scream of artificial control. Around closest approach, astronomers will scrutinize every detail of its path, searching for accelerations too fine to be explained by outgassing alone. A fraction of a millimeter per second could change everything. From there, Atlas pushes outward. On March 16, 2026, it brushes past Jupiter at a distance of about 54 million kilometers, the tightest pass to any major planet. Jupiter's immense gravity will bend its course slightly and give astronomers one last chance to probe the object under unique conditions. Juno, NASA's orbiter currently studying Jupiter's interior, has been floated as a potential observer, though such a maneuver would require fuel and risk the mission. The European Space Agency's JUICE mission, due to arrive around the same time, faces similar trade-offs. Even without direct spacecraft imaging, ground-based telescopes will capture Atlas against Jupiter's vast magnetosphere, offering clues about how interstellar objects interact with powerful planetary fields. After that, the curtain falls. Beyond March 2026, Atlas will fade from view, slipping back toward the dark ocean between the stars. Unlike periodic comets bound to the sun, this traveler will never return. Humanity has just one chance to study it, an 18-month window stretching from discovery in July 2025 to its disappearance the following year. That timeline is nothing short of extraordinary. Coordinated campaigns across Earth and space will track its chemistry, morphology, and trajectory. Every stage, Mars, the Sun, Earth, Jupiter, becomes both an observational checkpoint and a listening post, a chance to monitor radio bands for any echoes of 1977's unexplained transmission. The choreography feels almost scripted. Each encounter another prompt, another opportunity, as if the universe itself is nudging us to watch more closely. And so, the question deepens. Is Atlas simply an exotic comet passing through, or is it something more, a messenger wrapped in ice and dust, carrying answers we've been chasing since Jerry Eman circled "Wow" on a printout nearly 50 years ago? Part 10. Scientists divided. Normally, astronomy thrives on quiet consensus. Debates fought politely in journals and conferences, but Atlas has split the community in a way few objects ever have. For mainstream institutions, NASA, ESA, and leading observatories, the stance is clear: Atlas is a comet. Strange, yes. Outperforming expectations, yes, but still natural. Its coma and tail, its chemistry, and its gravity-driven trajectory all line up with what theory predicts. To them, the nickel-rich emissions and odd activity levels aren't signs of engineering, but signs of our ignorance. We've only seen 3 confirmed interstellar visitors. Declaring one artificial after such a small sample, they argue, would be like trying to map humanity's diversity after meeting 3 strangers on a street corner. Dr. Alan Fitzsimmons, of Queen's University Belfast, put it bluntly: weird chemistry should be expected. Stars form in different environments. Their planets and comets inherit wildly different compositions. From that perspective, Atlas isn't breaking rules, it's teaching us what's possible. But not everyone is convinced. Imagine looking up at the night sky and realizing that what we've always believed to be random, those faint signals, those strange interstellar visitors, might not be random at all. Imagine if what we thought were isolated mysteries are actually connected pieces of a much bigger puzzle, a message not sent through letters, not whispered through waves, but written into the very movement of the cosmos. What if every comet-like traveler, every unexplained burst of radio noise, was part of an ongoing conversation, one we've only just started to overhear? This isn't science fiction. This is one of the boldest ideas to come out of speculative science. The possibility that humanity has already received both a signal and a messenger. A signal in 1977, and a visitor decades later. Together they form what some now call the message in motion hypothesis. And if it's true, it means we've been participants in an interstellar dialogue without even knowing it. To understand why this idea has gained attention, let's step back to the foundations of the scientific method. Real progress doesn't come from dismissing strange correlations, it comes from treating them seriously enough to test. We look at the data, we craft explanations, we check them against reality, and when new evidence arrives, we adjust. In a universe where so far we've seen only 1 unexplained radio signal and just 3 confirmed objects from beyond our solar system, we can't afford to ignore coincidences. Every unusual alignment deserves careful study, because missing just one true pattern could mean overlooking the first proof that we are not alone. The message in motion hypothesis builds directly on this spirit of inquiry. It proposes something almost cinematic: that the famous WOW signal detected in 1977, and the mysterious object known as 3I/Atlas, might not be unrelated accidents of astronomy, but 2 acts in the same cosmic play. The WOW signal in this interpretation was not just a random burst of radio noise but an intentional beacon, an opening announcement crafted to be unmissable by any civilization with radio telescopes. The frequency was no accident either. It appeared near the hydrogen line, the universal marker in the spectrum that every radio astronomer studies. Hydrogen is the most common element in the universe, making this frequency a kind of universal calling card. And unlike natural emissions which sprawl across wide bands, this signal was tight, narrow, focused, like a laser beam across the galactic background. Whoever sent it, if it was sent, wanted to stand out. But here's where things move from intriguing to extraordinary. According to this hypothesis, the radio message was not meant to be followed by more radio messages. Instead, it was meant to be followed by something tangible. A second act, delivered not at the speed of light, but at the slower, more deliberate pace of matter, crossing interstellar space. That second act would be a visitor, a disguised probe, a comet-like object that was not entirely what it seemed. In this story, 3I/Atlas plays the role of that messenger. Outwardly it looks like a comet, shedding gas, glowing faintly, tracing a path through the solar system. But beneath the disguise, it could carry instruments, information, or even a carefully engineered package from another intelligence. The wow signal says, "Look at us, we're here." Decades later, the arrival of a physical body says, "And now we've come to you." The gap of nearly half a century between the two events begins to make sense in this light. Radio signals can cross the distance between nearby stars in just a few years, but moving matter, even with advanced propulsion, takes far longer. If the source lay 10, 20 or 30 light-years away, the timing matches perfectly. First, the signal races ahead, a scout moving at light speed. Then, years later, the probe follows behind at whatever speed physics allows. When Atlas reached our solar system, its arrival would seem uncannily aligned with that earlier burst of radio noise, transforming coincidence into choreography. Such a hypothesis explains mysteries that otherwise frustrate astronomers. The wow signal's refusal to repeat, for example, fits neatly if it was never intended to repeat. It was a single flare, an attention grabber, not an ongoing beacon. It also explains Atlas's oddities. The chemistry looked wrong for a simple comet, too rich in carbon dioxide and showing peculiar metallic emissions. Some of its outgassing seemed exaggerated, producing thrust out of proportion to its size. These anomalies could be seen as camouflage, the outer skin of a probe engineered to mimic natural behavior while concealing technological machinery inside. Even its orbit raised eyebrows. A retrograde path, low in inclination, could be the footprint not of randomness, but of careful steering, subtle course corrections to ensure it reached exactly the right place. If we treat this as a hypothesis rather than pure speculation, it leads to clear predictions, ways we might actually test it. One prediction is that Atlas, or objects like it, could emit structured radio signals of their own, perhaps when close to planets where conditions for transmission are favorable. These signals wouldn't just be static, they might carry modulation, harmonics of the hydrogen line, or mathematical sequences beyond what plasma interactions can explain. Another prediction is motion. A genuine probe might maneuver in ways that natural comets cannot. Non-gravitational accelerations, sudden trajectory adjustments, or sustained thrust, inconsistent with outgassing, would be a telltale sign. Third, the material composition itself might betray its nature. Spectral analysis could reveal metals in ratios unknown in natural formation, isotopes that don't match stellar processes, or synthetic compounds beyond chemistry's normal reach. Fourth, we could catch it glowing in unexpected ways. Thermal imaging might detect heat from engines, reactors, or electronics, patterns that don't match the sun-warmed ice of a comet, but suggest power generation. But of course, each of these possible signs comes with challenges. Nature is clever. Plasma around comets can produce strange bursts of radio waves that mimic artificial signals. Outgassing can accelerate a body in ways that look like thrust. Stars can create odd chemical mixtures that seem exotic to us but are ordinary in other systems. Even heat signatures can be misleading, since comets have complex interiors that produce unpredictable warming effects. Disentangling the artificial from the natural is never simple. Beyond the technical hurdles, there are logical ones too. Why would a civilization go to such lengths to communicate in such a convoluted way? Why not keep sending radio messages, simple and effective? Why hide a probe in a comet's skin rather than reveal it as clearly technological? The costs of building and launching such a mission would be immense, and the risks enormous. What if the probe were destroyed en route, or never detected at all? To our logic, it feels almost impractical. Yet perhaps that's the point. Perhaps we're not seeing the full strategy. Maybe the probe carries things that radio waves cannot. Artifacts, data storage, even biological material. Perhaps the disguise isn't for us, but for others. A way of traveling unnoticed through a galaxy where not every civilization is friendly. Or maybe their sense of communication is fundamentally different from ours, operating across scales of time and space that feel absurd to human minds but are natural to them. And then there's the deeper, almost unsettling question. What kind of beings would think this way? to coordinate a message across centuries, to launch a physical visitor as a continuation of a radio signal, requires patience, planning, and vision beyond anything in human history. What motivations would drive such an effort? Curiosity, a test, an invitation, or something stranger, a purpose we can't yet imagine? These questions remain unanswerable, but they remind us why considering such hypotheses is valuable. They force us to stretch our thinking, to see intelligence and communication in forms we might otherwise dismiss. At its heart, the message in motion hypothesis is less about proving that Atlas was a disguised spacecraft, and more about pushing the boundaries of what we allow ourselves to consider. It challenges us to connect dots carefully, to ask whether the strange might sometimes be deliberate. It reminds us that extraordinary claims demand extraordinary evidence, but that extraordinary evidence can only be found if we're willing to look. Whether or not the wow signal and Atlas truly form parts of the same conversation, the exercise of treating the possibility seriously sharpens our science. It keeps us alert to the chance that the universe may already be speaking, not in the ways we expect, but in ways we have yet to learn how to hear. Imagine for a moment the vast silence of space, a silence so deep that even the roar of stars, the crackle of cosmic radiation, and the whisper of ancient pulsars fade into background noise. Within that ocean of soundless infinity, humanity has placed its ears to the void, listening for the faintest sign that we are not alone. Most of the time, the universe responds with indifference, chaotic signals, static bursts of energy that come and go without meaning. But every once in a while, something stirs the imagination, a strange whisper, a fleeting pattern, a possibility too profound to ignore. And right now, the entire scientific world is holding its breath, because the mysterious traveler we call 3I Atlas is approaching its most critical chapters, and with it comes perhaps the most ambitious listening campaign in the history of human science. What we are about to attempt is nothing less than eavesdropping on a potential message from another intelligence. For decades, radio astronomers have refined the art of separating nature from artifice. They know how pulsars tick, how quasars flare, how galaxies emit background noise across the spectrum. They can predict cosmic interference the way meteorologists forecast rain. And yet, 3I Atlas complicates everything. This object, whether comet, artifact, or something in between, is giving us windows of opportunity to listen like never before. The upcoming months form a sequence of perfect alignments, as if written into a cosmic score. Each encounter, Mars, the Sun, Earth, and later Jupiter, creates a stage upon which any hidden transmitter might perform. Scientists call this the act of listening, but in truth, it feels more like humanity leaning forward in anticipation, trying to catch a secret that may change everything we know. The first major chance arrives with the Mars flyby in early October. At a distance of roughly 30 million kilometers, the geometry is striking. Mars becomes a gravitational player, its thin magnetic field stretching across space, its charged particles colliding with solar wind in ways that could trigger phenomena around a passing object. If 3I Atlas were designed to respond to such encounters, this is when subtle transmissions might begin. Astronomers imagine scenarios where the visitor wakes up when near planets, using them as cosmic checkpoints. Even if no signal appears, the very act of tuning every major radio telescope toward the object represents a historic moment. Never before has humanity conducted such a coordinated attempt to intercept potential interstellar communication. But the real crucible arrives weeks later, when the traveler swings dangerously close to the Sun. Late October brings perihelion, the point of closest approach. For any cometary body, this is a time of stress and transformation. Solar radiation pounds its surface, forcing volatile materials to vaporize, shaping tails that stretch for millions of kilometers. For a disguised machine, if such it is, this furnace would be the ultimate test. Hidden panels might unfurl, dormant systems might awaken, or heat might trigger responses designed to reveal or conceal the truth. Ground-based observatories will be blinded by the sun's glare, but orbiting instruments with specialized shielding, Hubble, the James Webb, and solar missions will keep watch. The scientific community knows that if anything extraordinary is hidden within the body of 3I Atlas, perihelion is when it will betray itself. And then comes December. Mid-month, the traveler makes its closest approach to Earth, about 270 million kilometers, nearly twice the distance between Earth and the Sun. That number may seem disappointingly large compared to comets that have dazzled the night sky in the past, but for radio science, it is close enough to matter. Proximity means signal strength. Proximity means precision in tracking. Proximity means the ability to listen continuously, as observatories across the globe take turns pointing their colossal ears at the same target. For the SETI community, this is the crown jewel of the campaign. If any artificial emissions exist, this is when we will hear them most clearly. The chosen listening bands are as symbolic as they are scientific. Special attention will be given to the waterhole, the radio quiet region between 1420 and 1670 MHz. It's here, nestled between the emission lines of hydrogen and hydroxyl, that many scientists believe any extraterrestrial intelligence would naturally choose to broadcast. After all, hydrogen and water are universal markers of life. This band is quiet in the cosmic spectrum, a kind of natural meeting place, and it was within this region that nearly half a century ago, the famous WOW signal was detected, a sharp, unexplained transmission that has never repeated. Now, with 3i Atlas passing through, astronomers will not only revisit that exact frequency, but will widen their nets, exploring harmonics, multiples, and entirely new bands of the spectrum. No one wants to miss a message, because they assumed alien engineering would think like us. The Breakthrough Listen initiative, funded by Yuri Milner, has already begun reserving massive amounts of telescope time. Their network is vast. The Green Bank Telescope in West Virginia, with its giant dish aimed at the skies, the Parker's Observatory in Australia, nicknamed the Dish, a legend in the history of radio astronomy, and South Africa's Meerkat Array, whose dozens of linked antennas create extraordinary resolution. Together, these instruments form a listening triad spanning continents, each compensating for the other's blind spots. When Earth rotates one telescope away, another rises to take its place, creating a near-continuous vigil. Meanwhile, China's FAST telescope, the 500-meter aperture spherical telescope, the largest single dish in the world, brings unmatched sensitivity. Its immense collecting area allows it to detect signals so faint they would be drowned out anywhere else. And perhaps most importantly, its location grants access to sky regions invisible from northern latitudes. FAST has only recently been turned towards SETI searches, but its contribution to the Atlas campaign could prove decisive. Detecting a signal, however, is not as simple as hearing a beep in the void. The real challenge is proof. Natural sources can mimic artificial ones. Plasma interactions can generate bursts that look deliberate. Cosmic noise can trick even the most advanced algorithms. That is why modern SETI employs a suite of strategies. One is Doppler tracking. As 3i Atlas moves through space, its relative velocity to Earth should create predictable frequency shifts, stretches and compressions in any emitted signal. If the transmission perfectly matches the object's orbital path, it could still be natural, but if it shows compensations, if it demonstrates a deliberate correction for Doppler drift, then we are no longer looking at geology or chemistry, we are looking at intent. Another method is polarization analysis. Radio waves have orientations, and natural processes typically produce random or limited polarization states. Artificial transmitters, on the other hand, can encode data or structure into polarization changes. Detecting circular polarization, rapid flips, or repeating polarization patterns would be as good as a technological fingerprint. To cover all possibilities, astronomers won't just scan radio, they will search in optical and infrared as well. High-power lasers, for example, can create pulses detectable across interstellar distances. If Atlas is transmitting, it might use beams of light, bursts invisible to the human eye, but glaringly obvious to sensitive detectors. Similarly, infrared monitoring might uncover waste heat inconsistent with natural cometary activity, perhaps evidence of internal machinery or energy storage. These scientific pursuits aren't limited to professionals alone. Citizen science has become a cornerstone of modern SETI. Distributed computing projects like SETI at Home proved years ago that millions of home computers working in parallel could sift through mountains of radio data more efficiently than a single supercomputer. Today, the spirit of that movement continues. Amateurs with backyard dishes or modest spectrometers are preparing to join the Atlas Watch, contributing tiny but meaningful pieces to the collective effort. For the first time in history, the search for extraterrestrial signals may unfold as a truly global event, involving not only elite observatories but everyday enthusiasts scattered across the planet. Beyond technology, however, lies the human element. The psychological weight of listening. What if we succeed? The protocols are clear. Multiple observatories must confirm the signal independently. All terrestrial interference must be ruled out. Only then would the discovery be announced, following guidelines set decades ago by the international SETI community. Even then, the questions would cascade faster than answers. What does the message say? Who sent it? Why now? And just as importantly, how would humanity react? Skeptics would argue hoax, nations would compete for control, philosophers and theologians would scramble to reinterpret their frameworks. The world might unite in wonder or fracture in fear. And yet, even if we hear nothing but silence, the attempt itself carries immeasurable value. Coordinating dozens of telescopes across continents, developing new signal processing algorithms, and engaging both professionals and amateurs represents a triumph of scientific cooperation. Silence can teach as much as sound. If no message exists, then we will have sharpened our tools, honed our skepticism, and better prepared ourselves for the next anomaly. For science, the act of listening is never wasted. Still, there is something undeniably dramatic about this moment. In a universe that has been silent for billions of years, we are daring to imagine that a faint whisper might soon reach us. Whether 3i Atlas proves to be natural or artificial, whether it carries secrets or simply dust, the campaign to listen to it stands as a milestone in human history. We are a young species, clinging to a small planet around an ordinary star, and yet we have built machines capable of hearing across the abyss. That, in itself, is extraordinary. As the campaign unfolds, nights will pass with radio dishes, quietly tracking the object, their motors humming as they sweep across the stars. Computer clusters will churn through terabytes of data, searching for patterns invisible to the human eye. Teams of scientists will wait, weary but alert, for any anomaly worth chasing, and millions of us, ordinary people staring at the news or sky, will wonder, are we finally about to hear another voice in the cosmic dark? Whether silence or symphony answers us, this act of listening is a testament to who we are, a species defined not just by survival, but by curiosity, by the refusal to stop asking questions, by the courage to lean into the void and whisper, is anyone there? And perhaps, just perhaps, 3i Atlas will whisper back. When we look at 3i Atlas, it's tempting to see just another comet drifting through the solar system, here for a brief moment before vanishing into the darkness. But the truth is much deeper. This mysterious wanderer represents more than a single anomaly. It embodies a fundamental shift in the way humanity understands its place in the cosmos. For decades we've looked up at the stars believing our solar system was isolated, a closed stage where planets and comets performed their eternal dance. But the arrival of objects like 3i Atlas reveals something startling. The universe is not a static backdrop. It is alive, constantly moving, constantly exchanging fragments of distant worlds. Every interstellar visitor is a traveler carrying with it ancient stories written in dust, ice, and minerals forged in environments far beyond the reach of our telescopes. These fragments are cosmic postcards, reminders that planetary systems are not closed loops but open theaters of creation, destruction, and migration. The scientific treasure locked inside these travelers extends far beyond speculation about extraterrestrial signals. Interstellar bodies act like fossils, preserving chemical records of conditions around alien stars billions of years ago. Our own comets hold similar information about the birth of the Sun, but comparing them with outsiders allows us to see whether the story of planetary formation is universal or whether it plays out differently under other stars. When astronomers measured 3i Atlas's strange carbon dioxide to water ratio, they saw something utterly alien. In our solar system, volatile ratios reflect temperature gradients that existed in the Sun's protoplanetary disk. Certain ices could only condense in cooler outer zones, while others formed closer in. If Atlas carries ratios dramatically unlike ours, it means it was born under completely different conditions. Perhaps its parent star was hotter, more massive, or enriched with heavier elements. Suddenly, this single visitor becomes a messenger from a world we may never see, telling us about environments where planets are born in ways we can barely imagine. Then there's the puzzle of the nickel emissions. On Earth, and throughout our solar system, nickel and iron tend to travel together. They're forged side by side in stellar furnaces, bound by the same nuclear processes. Yet, Atlas seems to glow with nickel, without the expected iron signature. This is not just unusual, it's almost like finding smoke without fire. Such an imbalance hints at processes we don't yet understand, perhaps exotic chemistry or rare physical conditions. Did Atlas form in a system where heavy elements condense differently, or are we witnessing a new type of cometary physics altogether? Each unexplained signal adds another piece to a grand puzzle that stretches across light years. Modern astronomy is uniquely prepared for this challenge. The James Webb Space Telescope, with its unparalleled infrared sensitivity, can peer into the molecular makeup of Atlas's coma, detecting compounds invisible to past generations. The Hubble Space Telescope still provides exquisite imaging, mapping the shape, spin, and brightness changes that hint at the object's hidden structure. On Earth, the Gemini Observatory and other powerful facilities monitor its every move, tracking how its tail develops under solar heating and how gas emissions evolve as it draws closer to the Sun. What makes this moment extraordinary is not just the technology itself, but the coordination. We are witnessing the rise of multi-wavelength, multi-observatory campaigns designed to squeeze every possible drop of knowledge from fleeting phenomena. Interstellar objects don't linger. They appear suddenly, give us a brief chance, and then vanish forever. Missing that chance means losing a once-in-history opportunity. With Atlas, humanity is refusing to let that opportunity slip away. But this is only the beginning. The arrival of Oumuamua in 2017 shocked the world as the first recognized interstellar visitor. Then came 2I/Borisov, and now Atlas. Each new arrival confirms that our solar system is not unique in attracting these wanderers. As detection technology improves, the floodgates are about to open. The upcoming Legacy Survey of Space and Time, conducted with the Vera C. Rubin Observatory, promises to revolutionize this search. It will scan the entire visible sky every few nights, capturing faint, fast-moving intruders that older surveys would have missed. Estimates suggest that within the next decade we may detect dozens or even hundreds of interstellar objects. With numbers like that, they will stop being isolated curiosities and become a new field of statistical science. We'll be able to chart patterns, which types of stars eject the most comets, which chemical fingerprints dominate across the galaxy, and how often bizarre anomalies like Atlas appear. For the first time, humanity will build a comparative database of alien planetary systems without ever leaving home. Atlas also highlights another transformation: the growing role of ordinary people in cosmic discovery. Astronomy is no longer the exclusive domain of massive observatories and elite scientists. Amateur astronomers, armed with sophisticated telescopes and tracking equipment, contribute crucial observations. Brightness variations, position shifts, tail structures, all can be documented by skilled observers scattered across the globe. Citizen science campaigns, like those run by Unistellar, are already gathering data on Atlas, turning living rooms and backyards into extensions of the global research network. Dozens of observations stitched together from around the world create continuous coverage professional facilities alone could never achieve. This democratization of discovery doesn't just accelerate science, it inspires a generation. Students, hobbyists, and curious minds become part of a collective project, touching the frontier of human knowledge with their own hands. The bigger picture, then, is not just about one object, it's about what that object symbolizes. Atlas embodies the idea that the universe is not static, not distant, but connected to us through the endless exchange of cosmic fragments. It forces us to think differently about our place in the galactic ecosystem. Just as Earth sends out its own dust, comets and asteroids into interstellar space, other systems are constantly seeding the galaxy with their own debris. These fragments are the DNA of worlds, drifting across the stars, waiting to be decoded. And when one of them lands in our observational reach, we get the chance to read a line of the galaxy's history. Imagine what this means for the search for life. Every time we capture an interstellar object, we are potentially holding a sample of chemistry shaped under alien conditions. Some may carry organic molecules assembled in environments completely unlike our own. Others may show us pathways to planet building we never considered. And yes, some might even hold evidence that challenges our assumptions about life's rarity. The fact that Atlas doesn't fit neatly into known categories reminds us that the universe is bigger, stranger, and richer than our imagination often allows. There's also a philosophical dimension to all of this. For centuries, humanity has looked at comets as omens, harbingers of change, sometimes feared, sometimes revered. In the modern age, we've stripped away that superstition, replacing fear with curiosity. Yet the emotional power remains. Watching a traveler from another star system streak across our skies taps into something primal. It's a reminder that we are not isolated. We are part of a galaxy filled with motion, exchange, and connection. Atlas is not just a scientific subject. It is a symbol of the human urge to reach outward, to make meaning from the unknown. As the data flows in from telescopes around the world, one thing is clear: this is a turning point. We are no longer simply cataloguing the solar system. We are beginning to catalogue the galaxy, piece by piece, visitor by visitor. The discoveries made with Atlas will ripple outward, influencing how we interpret future anomalies, shaping the strategies we use to hunt for extraterrestrial signals, and refining the models we build about how stars and planets evolve. In a sense, every observation of Atlas is practice for the future, for the day we may intercept not just a comet, but something truly unmistakably artificial. The bigger picture is that Atlas is both ordinary and extraordinary. On the surface, it may be just another lump of ice and dust, but beneath that lies a revolution in how we see ourselves and our universe. It is a reminder that discovery is not just about answers, but about expanding the scope of the questions we dare to ask. With each interstellar wanderer, we inch closer to a galactic perspective, one where Earth is not the center, not the exception, but one participant in a vast, dynamic, interconnected cosmos. And as long as we keep looking, keep listening, and keep questioning, we ensure that when the universe does speak more clearly, whether through comets, signals, or something we can't yet imagine, we will be ready to hear it. As humanity watches 3I Atlas carve its path through the inner solar system, we find ourselves standing at the edge of wonder and uncertainty. For the first time in our history, we are not just passive observers of the night sky, but active participants in a grand experiment. Never before have our instruments been so powerful, our coordination so global, and our curiosity so insatiable. And yet, even with all our advancements, we are humbled by the realization that every new discovery only opens more questions. The mysteries surrounding 3I Atlas and its curious connection to the infamous WOW signal remind us of something profound. The universe is not finished surprising us. The WOW signal of 1977 was, in many ways, a spark that lit a fire of speculation, debate, and relentless investigation. That short burst of radio energy, so powerful and so precise, hinted at the possibility that we were not alone. Jerry Amon's handwritten WOW on that printout became more than a notation. It became a symbol of hope, of curiosity, and of the thrilling possibility that intelligence beyond Earth had reached out across the stars. Decades have passed since that moment, and still, the mystery endures. No identical signal has ever been detected again, and skeptics argue that it might have been a natural or terrestrial anomaly. But the fact remains, it was strong, it was real, and it forced us to confront a possibility too significant to dismiss. Now, in 2025, the arrival of 3I Atlas feels like an echo of that earlier moment. An interstellar visitor, strange in both composition and behavior, moving through our solar system as if scripted to rekindle that lingering question: was the WOW signal truly artificial, and could Atlas somehow be related? Perhaps the connection is only coincidence, another case of human pattern-seeking projected onto the cosmos. But even if that's true, both the signal and the object serve the same purpose. They push us to think bigger, to test harder, and to keep our ears open to the whispers of the universe. What makes this moment so extraordinary is not just the possibility of alien involvement, but the sheer scope of human effort now unfolding. Around the world, radio telescopes are listening with unmatched precision, their massive dishes sweeping the skies in search of even the faintest hint of structured transmissions. Algorithms pass data in real time, sifting through noise, discarding false positives, and flagging anomalies. Teams of astronomers coordinate across continents, ensuring that no potential signal goes unverified. This is not a solitary project. It is a global chorus of curiosity, united by a single question: are we alone? The act of listening itself is profound. It represents more than just a scientific process. It represents a statement of identity. By listening, we declare that we believe communication is possible, that intelligence may not be limited to Earth. Every hour of observation, every terabyte of data recorded, is an act of optimism. It says we are willing to invest energy and resources, not for immediate gain, but for the hope of connection, however slim that hope may be. This willingness to listen across the void reflects the most adventurous aspects of human nature. And yet, caution remains, just as essential as curiosity. The scientific method demands humility. Extraordinary claims require extraordinary evidence, and in the case of extraterrestrial intelligence, no claim could be more extraordinary. That is why every potential detection undergoes rigorous testing, replication, and verification. Multiple observatories must confirm results. Terrestrial interference must be ruled out beyond doubt. Only then can the world be told. This careful, disciplined approach is not skepticism for its own sake. It is the only way to ensure that when the day comes, when a true signal is detected, the evidence will be undeniable. Whether or not 3I Atlas yields that breakthrough, the process itself is invaluable. Every observation sharpens our tools. Every null result refines our search. Every anomaly forces us to improve our methods. By studying Atlas, we are preparing for the future, for the inevitable day when another object, another signal, or another unexpected discovery presents itself. This is not the end of a story, but the training ground for stories yet to come. The broader significance of these efforts reaches beyond science. It touches philosophy, culture, and identity. The search for extraterrestrial intelligence is at its core a reflection of humanity's deepest questions. Are we unique, or are we part of a larger community? Is life common in the universe, or a rare accident? And if intelligence has emerged elsewhere, what does that mean for us, our future, our survival, and our place among the stars? By pursuing these questions with rigor, we demonstrate not only our intellectual maturity, but also our courage. We are daring to confront possibilities that might change everything we know about ourselves. The journey from the WOW signal to 3I Atlas illustrates another crucial lesson: the importance of persistence. For nearly 5 decades, researchers have searched the skies, often with little to show for it, but silence, yet they have never stopped. That resilience, that refusal to give up, reflects a truth about human progress. Breakthroughs rarely come easily. They require decades of preparation, patience, and repeated failure. But every once in a while a breakthrough arrives, and when it does, it changes everything. Perhaps Atlas will turn out to be nothing more than an exotic comet, unusual but natural. If so, that discovery is no less valuable. It will expand our understanding of interstellar chemistry, provide a rare sample of material forged around a distant star, and give us a clearer picture of the galaxy's diversity. Perhaps Atlas will remain mysterious but ultimately unprovable, another puzzle added to the long list of cosmic enigmas. Or perhaps, though the odds remain slim, it will reveal something truly extraordinary, a deliberate signal, a clear sign, a message that humanity has been waiting to hear. No matter the outcome, one truth remains constant. We are listening, and in listening, we prove that we are ready not only to detect but to interpret, to question, to understand. The next wow moment may not come today or tomorrow. It may not even come in this generation. But the groundwork we lay today ensures that when it does arrive, humanity will recognize it for what it is. The cosmos is vast, and its silence profound. But silence does not mean emptiness. Silence is only the space between notes in a much greater song. As 3I Atlas approaches its critical encounters with Mars, the Sun, and eventually Earth's orbit, it carries with it more than dust and ice. It carries the hopes of billions of curious minds, the labor of thousands of scientists, and the dreams of a species determined to know whether it is alone. The story of Atlas, like the story of the WOW signal, may end in ambiguity, but both stories prove the same point, that the search itself is worth everything, because in searching we define who we are. We are not content to live in ignorance. We are not satisfied with easy answers. We are explorers, listeners, questioners. We are the species that refuses to stop asking. The next WOW may not come from a radio telescope. It may not come from a comet. It could arrive in a form we cannot yet imagine, from a source we cannot yet predict. But it will come. The universe is too vast, too ancient and too dynamic for us to believe otherwise. And when it does, whether through faint radio whispers, flashes of laser light, or artifacts drifting between the stars, humanity will be waiting, listening, watching, ready to respond. So as we stand here, on the edge of mystery, we must remember this. The WOW signal was never just about a single transmission, and 3I Atlas is not just about a single comet. Together they represent our journey from wonder to inquiry, from silence to listening, from ignorance to understanding. The universe has spoken before, and it may speak again. All we have to do is wait, prepare, and keep our ears open to the cosmos. Because the next WOW is coming. The only question is, will we recognize it when it arrives? We are steadily constructing the foundations of interstellar communication, building systems that can not only detect and analyze strange signals, but also verify, interpret, and eventually respond to potential transmissions from civilizations beyond our world. What makes this effort extraordinary is how far it reaches beyond traditional science. Students, hobbyists, and entire communities are taking part. Young people are poring over telescope data, amateur astronomers are contributing observations from backyard setups, and countless ordinary people are following along, asking timeless questions about meaning, purpose, and whether humanity is truly alone. For the first time in history, the search for intelligence among the stars has become a collective human project, one in which curiosity belongs not to a handful of researchers, but to our species as a whole. The next few decades promise transformations we can scarcely imagine. Surveys like the Legacy Survey of Space and Time will dramatically expand our catalogue of interstellar objects. Instead of a handful of known wanderers, we may have hundreds, even thousands, giving us a population large enough to reveal patterns about how solar systems form, evolve, and eject material into the void. Meanwhile, new generations of radio telescopes will reach sensitivities far beyond what we currently possess, scanning wider swaths of the spectrum for even the faintest whisper from distant intelligences. Space telescopes such as the James Webb and the even more ambitious instruments that will follow it will peer into alien atmospheres with precision, searching for chemical traces that betray biology, or perhaps technology. Interferometry techniques on the horizon may one day allow us to capture images of Earth-like worlds orbiting nearby stars with detail unimaginable today. Bit by bit, we are closing in on answers to questions that were once purely the domain of dreamers. But perhaps the greatest advance won't come from hardware at all. It will come from us. From the slow, steady growth of our cosmic perspective. Every unexplained signal, every null result, every strange object forces us to clarify what we believe is possible, what we think is likely, and what mysteries remain beyond our grasp. The tentative link between the WOW signal and 3 Atlas has already served this role beautifully. Whether or not the connection turns out to be real, it has sharpened our tools. It has forced scientists to design better statistical frameworks for separating coincidence from causation. It has pushed us to invent more sophisticated ways of interpreting anomalies. And it has demanded stricter protocols for deciding what counts as natural and what might hint at the artificial. Even if the link proves purely accidental, the intellectual infrastructure we've built to investigate it will remain. This is the pattern of astronomy itself. Time and again the universe confronts us with the unexpected. Pulsars were once thought to be artificial beacons, until their true nature as neutron stars was revealed. Pulsars stretched our understanding of galaxies. Dark matter and dark energy forced us to acknowledge that most of the cosmos is invisible and mysterious. Each revelation has expanded our imagination and reshaped our models of reality. The search for extraterrestrial intelligence may prove to be the most challenging of all, because unlike mapping galaxies or measuring radiation, here we are hunting for intent, for artifacts or signals crafted by unknown minds, driven by motives we can only guess at. To pursue this path is to face not only physics and chemistry, but philosophy, psychology, and the very definition of intelligence itself. Both the WOW signal and 3 Atlas, regardless of their ultimate explanations, serve as lodestars in this wider journey. They illustrate the kind of anomalies we must be prepared to face. They remind us of the fine balance between skepticism and imagination, between scientific caution and the human hunger for discovery. And they demonstrate the extraordinary challenge of searching for contact in a universe where nature itself often produces wonders stranger than fiction. At this moment, we live in a rare state of productive uncertainty. We know the possibilities are astonishing, but we also know how little we understand. That tension, hope coupled with humility, may be our species' most valuable intellectual achievement. It prevents us from leaping too quickly to conclusions, yet it keeps us reaching, listening, and searching with open minds. The story of the WOW signal and 3 Atlas is not just about aliens or comets. It is about humanity's graduation into a truly cosmic identity. For most of history, we were passive observers, gazing upward and cataloguing the heavens. Now, we are active participants, listening intently for voices in the dark, ready to notice the faintest flicker that might betray another intelligence. This shift is profound. It marks our transformation from a civilization confined to its own world into one that understands itself as part of a far larger conversation, even if we have not yet heard a reply. The ultimate question remains hauntingly open. Are we alone? The odd pairing of a mysterious radio burst from 1977 and an enigmatic interstellar object in 2025 does not answer it. But it does give us something equally powerful, a blueprint for how to chase the answer responsibly. It reminds us that great discoveries rarely arrive neatly packaged. They come in fragments, coincidences, and anomalies that demand patience, creativity, and persistence. As 3 Atlas completes its path through our solar system, we inherit the legacy of astronomers who came before, their patience, their daring, their relentless curiosity. The night sky that baffled them still baffles us, but we now possess tools and methods they could scarcely dream of. The next WOW moment could erupt at any time, tomorrow, next year, or decades in the future. It might come as a faint radio pulse, a glimmer of light on a telescope's sensor, or an interstellar traveler whose very structure makes its origin unmistakable. When that day comes, we will be prepared. We have built the instruments, we have agreed upon the protocols, we have cultivated the mental frameworks to separate illusion from evidence. Most importantly, we have preserved the wonder that fuels discovery itself. The cosmos is vast beyond comprehension, filled with more stars than grains of sand, more worlds than we could ever visit, and more possibilities than we can currently imagine. In such a universe, extraordinary events are not merely possible, they are inevitable. The mysterious pairing of a radio burst and a wandering object is a reminder that the cosmos is still capable of surprising us, and that the boldest possibilities may be the ones we should take most seriously. As we close this chapter, we do not end with certainty. Instead, we end with sharper questions, stronger methods, and deeper humility. The secrets of the universe remain intact, but our pursuit of them has made us wiser. Whether we are alone, or one among many, the search itself gives meaning, it elevates us, connects us, and places us within a story far larger than Earth or humanity alone. Perhaps that is the greatest revelation of all, that by daring to ask if we are alone, we are already part of something bigger. The courage to wonder, to search, and to reach into the infinite darkness is itself the proof that we are ready for whatever waits beyond the stars.